Hello everyone. Before starting the lesson, try the warm-up. Are these functions periodic? These are the functions I'm talking about. And a follow-up question, are these functions sinusoidal? So pause the video and see if you can answer these questions. So first off, are these functions periodic? This one is, whereas this one is not. This one has the exact same pattern repeating. So I can see here's one complete cycle from here to here, and that exact same cycle repeats from here to here. Whereas for this one, sure, it looks like I have something repeating, but it's not exactly the same. This part is smaller than this part. So from what I can tell, this is not a periodic function. Are these sinusoidal? Well, because this one is not periodic, it can't be sinusoidal because a sinusoidal function is a type of periodic function. So is this one sinusoidal? Well, it's not sinusoidal because even though it looks like a wave pattern, it's not a wave with a constant amplitude. So we see waves of differing heights throughout. A sinusoidal function would have a constant amplitude throughout. We wouldn't see different sized waves, in other words. Now, in this lesson, we're going to talk about transformations of sinusoidal functions. So we're going to relate transformations of sinusoidal functions to their graphs and equations. We have talked about transformations of functions in general before and with quadratic functions. Now we're going to talk about how these impact sinusoidal functions. Now here's something to remember. For a sinusoidal function, the parent function can be sine x or cos x. Both of these parent functions give you that wave pattern that we recognized from the previous lesson. So you can base the equation for your sinusoidal function off of either of these. So remember, we have A, K, D, and C values. These are just the placement of the numbers in your equations. Now, depending on where you're inserting a number into your parent function, that will correspond to a certain change that you're making on its graph. So if you change the A value, that changes your vertical values on your graph. If A is negative, you'll have a vertical reflection from the parent function. And then, if the value of your A is greater than 1, you'll have a vertical stretch. If it's less than 1, you'll have a vertical compression by that amount. K is similar, except instead of talking about vertical, it's horizontal. So you can have horizontal reflections or horizontal stretches and compressions. D values are for your translations left or right. C values are translations up and down. So just remember, if you change the equation of the parent function, it will give you a corresponding change in the graph. That's what transformations are. Now, in the past, when I've told you to make a graph from an equation, we usually graph the parent function first. Then we list the transformations, and we apply all the transformations to a few points on the parent function. That's typically how we've been doing it so far. It's harder to do that with sinusoidal functions, though, so I'm going to show you a different way that we can graph sinusoidal functions. And most people find that this is a little easier than trying to do it this way. So I call this the box method. First, you draw a box like this. So I cut the box into sections. Vertically, I cut it in half. Horizontally, I cut it into quarters. That's what I mean by drawing a box. You'll understand why I do it this way in a little bit. Now I'm going to label the axis, the maximum, and the minimum values. Those are your y values. Now, if you'll recall from the previous lesson, The maximum and minimum values for these parent functions are 1 and -1. So on the y component of my boxes, I label the maximum and the minimum. Also, the axis, remember the central axis goes right through the middle, which is at y = 0. So I can label the axis, the maximum, and the minimum on the vertical part of my box. Next, I'm going to label the beginning and end of one period. So I'm going to start at 0, and I know the period is 360 degrees, so I'm going to end at 360. Now I can get a little more detailed too. Notice these other vertical lines. I can figure out those values. The middle one is halfway between what I'm starting at and what I'm ending at. So halfway between 0 and 360 is 180. And halfway between 0 and 180 is 90. Halfway between 180 and 360 is 270. So I've labeled my axis, my maximum, my minimum, my beginning, and my end of the cycle, and I've filled in a few more details. Next, sketch the sine or cosine curve in the box. If you'll recall from the previous lesson, y = sine x starts here on the central axis. Now, in one complete cycle, it's going to end in the same spot. Halfway through, it's going to be in the middle. From the beginning, it goes up first to reach its maximum, then down to reach its minimum, and then back up to where it started. And then I can just draw a smooth curve through those points. So this is one complete cycle of y = sine x. I know where it starts, I know where it ends, I know that it goes up first, then down, and then back up to where it started. Now with y = cosine x, we have the same maximum, the same minimum, the same central axis, the same beginning, and the same end in one complete cycle. We're just starting in a different spot. For cosine curves, we're starting at the maximum, which means we'll end at the maximum. So from the maximum, we're going to go down to the minimum, then back up. So this would be one complete cycle of the cosine curve, starting at 0 and ending at 360. Now, you can draw this really quickly with practice because these parent functions always have the same maximum of 1 and the minimum of -1 and the central axis at 0. Start at 0, end at 360. They just start their cycle in a different position. Sine x starts on the central axis, whereas cosine x starts at the maximum. So once you've sketched your curve in the box, then you can start actually making a graph. You've figured out where these key points are with all their x and y values, so you can plot those more easily on a graph to make an accurate graph. And you can just copy the box for the desired number of cycles. So I'm going to walk you through this first example. We're going to graph the function using the box method that I explained earlier. So here's our function this time. Notice I've made some changes to the parent function of sine x. I have an a value of 2 and a c value of -1. So I have a vertical stretch times 2 and a translation down 1 unit. But let's go through the box method. First, let's just think about how this relates to the parent function. I'm going to base my drawing off of this one. So I'll draw a box here just to figure things out. Start with the central axis. In my parent function, the central axis was 0, but I have a vertical translation down 1 unit. So that's going to move my central axis from 0 down to -1. So you can think of the c value as the central axis. That's a little shortcut, c for central axis. Okay, now my maximum and my minimum values. Well, my maximum value is no longer going to be 1 because, first off, I've moved everything down 1 unit, but also I have this vertical stretch. My curve is going to be twice as tall away from the central axis. So that A value actually tells me what the amplitude is. A for amplitude. That's another shortcut. If the amplitude is 2, that means I'm going to go up 2 from my central axis and down 2 from my central axis. This tells me what my maximum and minimum values are for this function. So just to recap, C value tells you the central axis. A value tells you the amplitude, which you use to figure out the maximum and the minimum values. Now let's think about the start and the end of the cycle. Well, have we moved left or right? No, I don't see a D value in there. So my starting point is at the same spot. I'm going to start at 0. And has the period changed? Well, no, because I don't see a K value in here. K value dictates the horizontal stretches or compressions. If it hasn't been stretched or compressed horizontally, then the period has remained the same. So I'm going to start at 0. The period is still 360, so I'm going to end at 360 as well. So these values have not changed because I haven't had any changes horizontally in my equation. There's no K or D values to make horizontal changes. Now I can draw the curve in my box. The only thing I have to look out for is, does it open the same way in the same direction, or does it vertically reflect? Well, if my A value is positive, then I know it's going to start here and go up, just like this one did. So I know I'm going to start on my central axis because this is a sine curve, not a cosine curve. I'm going to go up, then back down to the minimum, and back to where I started. So this is one complete cycle of my function g of x. Now to make an actual graph, I can use the points that I figured out in the box method. So let's put a scale on our graph on the x and y axes. So for my function, when x is 0, y is minus 1. Put that on the graph. When x is 90, y is 1. Put that on the graph. When x is 180, y is minus 1 again. And you can keep going. When x is 270, y is minus 3. And when x is 360, y is minus 1 again. So you can see I'm just using this box to figure out where to accurately put my points on the graph. So now I have a fairly accurate graph of one complete cycle of my function g of x. And if I want to graph more than one cycle, well, I can just copy this over here. My box is here. I can just copy the same box over here. I know I'm going to start on the central axis. In the middle, I'm going to be on the central axis. Halfway between those 2 points, I'm up at the maximum, and here's where I would be at the minimum. So now I have 2 complete cycles of my function g of x accurately drawn on the graph using the scale that I have on the grid. Now I just want to remind you about domain and range. Think about domain and range for a second. If you'll recall, domain is all the possible x values and range is all the possible y values. Well, domain is x is an element of the real numbers, no restrictions. I could copy and paste this box forever and ever going to the right. I could copy and paste it forever and ever going to the left. X can be any value along the x-axis, so there's no restrictions. For the range, though, there are restrictions because I have this maximum and minimum value of y. Y will never be less than -3, and it will never be greater than 1. So this is how I would write that. Y is an element of the real numbers with the restriction that y must be greater than or equal to -3 and less than or equal to 1. Y is in between -3 and 1. It can also equal -3 and 1. That's how I write that. Y can be any value in between -3 and 1. Okay, so we've gone through a few things here. Look at whether you're using sine or cosine as the parent function. Look at where your central axis is. Look at your amplitude. That can help you figure out your maximum and minimum values. Your start and end values remain unchanged unless you have k or d values in your equation. If you have a vertical reflection, then your curve would go down first instead of up first. And once you've figured out your box for your function, you can use that to make an accurate graph and make as many cycles as you want on the graph. In this next example, we have cosine as the parent function. So just remember, this is what the cosine parent function looked like. So I'm going to draw a new box and think about, where's my central axis? Well, remember I said the C value is where the central axis is. That would be over here. I don't see anything. That means the central axis is 0. I haven't had any vertical translations up or down, so my central axis remains unchanged. Now, how about my maximum and minimum values? Well, remember I said the A value tells you the amplitude, A for amplitude, 0.5. So my amplitude is 0.5. So I'm going to go up 0.5 from my central axis and down 0.5 from my central axis. That tells me the maximum and minimum. My starting value. Have we had a translation left or right? Well, no, I don't see a D value in here. So my starting value is still 0, but I have a K value of 2 here. Now be careful with the K values. This is not a horizontal stretch. This is actually a compression. Think of it like this. You can fit 2 complete cycles in the amount of space it used to take for 1 complete cycle. That's how you can think of the K value. So really, if you can fit 2 complete cycles in the span of 360 degrees, that means 1 complete cycle would take half as much, 180 degrees. Or just remember this. The period of your function is equal to 360 divided by k. In our case, k is 2, so 360 divided by 2 is 180. That means our period is 180. So from my starting point on the x-axis, I'm going to go up 180 degrees to get to the end of my first cycle. So I'm going to start at 0 but end at 180 this time. Now I can figure out what these values in the middle are. Halfway between 0 and 180 is 90. Halfway between 0 and 90 is 45. And halfway between 90 and 180 is 135. So I've got all the numbers figured out. Now I need to draw the curve. Notice that A value is negative. All that means is we have a vertical reflection. So instead of starting at the maximum and going down first, we're going to start at the minimum and go up first. So we're going to start at the minimum and then go up to the maximum and then go back down to the minimum. So this is going to be the look of our function. Now to make the graph, I'm going to use the same scale as I did in the previous example. I'm going to draw a box for 1 complete cycle. So I know my maximum is 0.5, my minimum is -0.5. I'm starting at 0 on the x-axis and ending at 180. So I've drawn that on here. Now to plot the points, I know I'm going to start in the bottom left corner. I'm going to end in the bottom right corner. In the middle, I'm going to be at the top. And halfway in between, I'll be on the central axis. So then I can very easily plot my points without having to pay a whole lot of attention to the scale. I don't have to plot the parent function first and then perform all these different transformations to each point. I don't have to individually do a vertical reflection, a vertical compression times 0.5, and a horizontal compression times 1/2 to each point. I just have to figure out the box and draw the box. And I can just use the pattern I find in my box, and I can repeat that pattern as necessary for as many cycles as I want. And I can find the domain and the range the same way as I did before. No restrictions on x because I can repeat this pattern an infinite number of times in any direction. And the range has these restrictions. Y must be between -0.5 and +0.5. And I can get that from the maximum and minimum values on my box drawing. So now I'd like you to try this one on your own. Here's my function. 1.5 cosine of x minus 60 plus 0.5. Pay attention to where the central axis is and what the amplitude is. Notice that we've moved the starting point right 60. So we're not going to start at 0, we're going to start at 60. So try making a box drawing and then check back in to see how you did. My central axis is 0.5. My amplitude is 1.5, so from the central axis, go up 1.5, you're at a maximum of 2. From the central axis, go down 1.5, you're at a minimum of -1. We have a vertical translation right 60 degrees. So instead of starting at 0, I'm going to start at +60. I don't see a k value here. That means it's unchanged, which means the period is unchanged. The period is still 360 degrees, but we're starting at a different value. So if I add 360 to 60, I end up at 420. My a value is positive, so there is no vertical reflection. So the cosine curve starts at a maximum. I haven't reflected it, so I'm still starting at a maximum and going down, then back up. So now that we have the box drawing, we can figure out a graph. So I'm going to use the same scale as I did before on my x and y axes. I'd like you to actually try this one on your own. See if you can take the box drawing and make an accurate graph using a scale like this. So pause the video and try this on your own. Now, when I made this, I'm starting at 60, ending at 420, that went off my chart, but I know it's going to be over here somewhere. So I just kind of drew this in to help guide me as I was drawing my graph. I can draw one complete cycle over here, though, because I know how many boxes or how many squares on the grid it should be. So start at the top, end at the top, go to the bottom in the middle. Halfway between those points, you're in the central axis. Connect the dots. Now I just stopped here. I put an arrow to say it would keep going. I just ran out of space on my grid. This was just here to help guide me. I can draw an arrow here to say that it keeps going. But here I have a fairly accurate graph taking up lots of space on the grid, and I didn't have to do any figuring out with transformations of each point of the parent function. I just drew the box and then redrew the box onto the scale provided. And again, domain and range can be figured out this way. No restrictions on x, but the minimum and the maximum values give restrictions for the y values. So we're going to graph this function using the box method. Notice I have a, k, d, and c values this time. Why don't you pause the video and see if you can come up with the box and then make an accurate graph using a scale like this. So pause the video and try this one on your own. The central axis is 4. The amplitude is 3. So from my central axis, I'm going to go up 3 and down 3. That gives me my maximum value of 7 and my minimum value of 1. The D value says I move the graph left 60, so instead of starting at 0, I'm going to just start at minus 60. K is 2, which means the period is 360 divided by 2, which is 180. So from the start to the end of the cycle, I'm increasing by 180. So if I'm starting at minus 60, add 180, I end at 120. My A value is positive, so my sine function doesn't change direction. I don't have a vertical reflection. I go from the central axis up at the start, then back down and back up again. Now to turn this into the graph, I can draw the outline of my box using the scale provided. On the x-axis, I'm starting at minus 60, so that's over here. And I'm ending at 120, that's right here. My y value minimum is 1, maximum is 7. So I have the outline of my box. Now to draw the actual graph, start on the central axis, end on the central axis. Halfway through, you're on the central axis again. Now in the middle between this point and this point, that's the middle right there, I'm up at the maximum. And halfway between this point and this point, that's here, I'm down at the minimum. And now I can just draw a smooth curve, and there's one complete cycle on my graph. If I want to fill the grid, I just make more cycles. So I can just draw more boxes, fill in my values. Don't even really have to look at the scale at this point. I'm just saying start and end at the same spot, halfway between those, halfway between those, halfway between those. Just counting boxes on the grid. And I can draw a curve through all my points, and I can add arrows to indicate that this pattern keeps going over and over again. And I can write my domain and my range the same way I did before. Now this is my last example for this lesson. Write an equation for a sine curve that has the following properties. The central axis is y equals 5, the period is 120, the amplitude is 6, and there's a phase shift of 60 to the right. Phase shift is just another way of saying a horizontal translation. So first off, the central axis is y equals 5. Well, I know C for central axis. My C value in the equation is 5. I know this one. I'm going to skip the period for now, but amplitude is 6. Well, A for amplitude, A is 6. And if I'm moving 60 to the right, that means D is 60. Now let's go back to this period. Remember earlier I said the period is equal to 360 divided by K. Well, I know the period is 120, so that means 120 is equal to 360 divided by K. Well, if that's true, then K would equal 360 divided by 120, in which case K is equal to 3. So it says write an equation for a sine curve. So I'm going to use sine x as my parent function. I just need to fill in the values for A, K, D, and C. I've already figured those out, so I just have to plug in A is 6, K is 3, D is 60, and C is 5. This equation is for this curve. So I've talked about graphing a sinusoidal function using the box method. You can find the central axis, the maximum, the minimum, the starting and the ending points, and then just draw your curve. Once you have the box, you can put that onto a grid using a proper scale, and you can make an accurate graph. You can also look at what the transformations are and work backwards to figure out what the equation of the sinusoidal function is. All this takes practice, so if you run into any issues while you're practicing, reach out for help.